Yep. Good thing it was a drill bit and not the end mill. So that end mill would have peeled my skin off. Lifting the vise off, wasn't paying attention. Mill wasn't even going. Good thing the end mill wasn't on there, because that would have really tore me up good. This is the beginnings of the anodizing tank cooler. These are the radiator blocks. This is the intake. This is the outtake, whatever. What we have is we have the fluid coming in, and I've got splitters here. So there will be one hose coming in, it'll split off. And I got a really long drill bit, so I'll be drilling down 2 holes in both of these. The first process on the mill today, I'm going to be drilling and reaming for this tubing, and this tubing is going to plug in. So the first process on the mill is to start these holes so I can tap and get these in place. But this is the overall setup for the anodizing tank. This will sit in the little fridge I got, and the water will be up to here. The lines will start below here, and so the water will already be cold, and this will be hooked up to a temp controller. Well, there will be a temp controller hooked up to the tank, actually monitoring the temperature. So when the tank gets up to about 69 degrees, we know it's going to hit 70, so the temp controller will turn on. Water will start flowing, or the anodizing solution, which is water and sulfuric acid, will start flowing through here into the radiator block, down the 2 lines, in through the hose, the tubing there, back into here, and then back out into the anodizing tank. The idea is to keep the anodizing tank between 60 and 70 degrees. Probably I will have it set at 65 degrees and just kind of keep it at an in-between. But we don't want the anodizing tank to get warmer than that, because it'll affect the anodizing process. This will sit in the fridge continuously. This is actually too big for the fridge, and as you see, I had to cut some of the lip off to get it to fit. I'm going to start the hole with this. I'm going to mount it, which you'll see in a second. We'll drill the initial holes. Once that's done, I'm going to move this entire setup over out of the way of the mill, and then with the long drill, I'll have to hand drill the remainder of the hole all the way down, because there's just not enough room to put this in the mill and get this table low enough. It's just not going to work. So we'll start it with this. That way, I'll have this much in here. So this will go down straight past that. So this is kind of acting as the initial guide to keep this from, I've got such a long block. I don't want to be drilling, because when you're hand drilling, that's what's going to happen. It's going to wander. Setup is zeroed. That way, I'm ready to mount it up. Pretty simple setup. I'm only drilling through plastic, so I don't need anything really monstrous, so it's pretty solid. And we're drilling for these. So as you can see, I'm drilling kind of off center. So I've got plenty of room to mount that, but what I want when I start drilling in and reaming for the tubing, I want to have a lot of surface area to hold the tube, because I'm going to be gluing it in there. It's a pretty snug fit, so I want to make sure once that's in and glued, it's not coming out, and I've got enough that it's going to hold. So we're going to get this drilled, and then I'm just going to drill it by hand. It's a pretty easy process. 4 holes, 1, 2, 3, 4. What's interesting, even though this is plastic, that drill bit still gets hot. So what I don't want to do is overheat this and I melt the plastic. I think that's good enough right there. Right. Sorry for the shakiness. My camera setup is needing some hard drives, so I have to record off the phone. So until I get those hard drives and set the camera up again, I just got to kind of hold the phone with my hand. Right there.
So yeah, I just went ahead and touched the drill bit there, and it is freaking hot, man.
So I got the stuff moved away. I got clearance. I got my drill. That's where I need to stop so I don't go all the way through to the bottom. So I will be able to do this by hand and should have no problem now that I've started the holes to drill straight down where I need to be. And I have to do this off camera because I need both hands. Yep, going badly. This it's getting hot really quick, and I'm just like barely this far, and it's getting hot. The plastic's getting hot, and it's just grabbing the bit, and it's taking everything I have to pull it back out. So I have to let it cool down and drill a little bit more. Yeah, this is going to take a while. This is really not going well. Just gonna use water to cool the bit and just continue to work it until I get to where I need to go. Still on the first hole. So I got the hole drilled. Couple things I learned here. Silicone lubricant doesn't work. Gotta keep the drill bit cool. Gotta have some clearance. And then chip loading. This thing loads up really quick. And when you load up with chips, what happens is there's nowhere for them to go. And so they wind up building up and pressing against the wall, and then it jams up even more. Just kind of got to work at it. I've been at this for like an hour just for that one hole. I'm going to take this block off, go inside, wash it out, see if I can get that silicone smell out of there. If I can't, and I might have to buy another block and start over. Day 2, drilling this out. I'm drilling all 3 holes in sequence so I can allow each hole to cool off between drilling. But I gotta tell you, I've been at this all day. This is just going really, really slow. I'm almost done with this one, but these 2 are gonna take a while. So I finally, after all day, that's almost 8 o'clock, got the holes drilled down those blocks. So what's next is I'm gonna be tapping for these. So I already did a test tap before I go and ruin my blocks, and I'm glad I did this. So I mean, this threads in, but it's not as tight as I would like, and even though I'm going to have glue on here, I want something a lot more snug. So what I did wrong on that was that I figured, well, I've got that much thread, so I'll drill that deep. And so that's what I did. I drilled that deep. And so this is a pipe thread, so the deeper I go, the bigger this gets. But if you see, I've only got that much there, so I didn't even need to do that. So what I've done is I've marked off how deep I need to go next time, and this is a lot shallower, so that will give me a much tighter fit when I screw that in if I only go this far. And I tried to measure from actual thread where I have a decent depth of thread. And so then I also figured I need to limit how deep I go with the drill. It's because I would like this bottom to bottom out against where this stops. So if you can see where the drill stopped in there, that's what I want. the bottom of this to bottom out on. So that way I can snug it down. And I don't think that in itself is going to, stop any. I'm sure it'll leak a little bit, but between that and the tight threads, and then right around this area, I don't want to mark on it. So just a little bit here is where the glue is going to go. I don't want to glue this whole thing. I just want a little bit of glue here, and that will ultimately seal it. But what the glue is more or less going to do is hold this in there, so when this is under pressure, it's not going to come popping out. Because this is plastic, and I am worried about these threads. It's polyethylene. It's not the hardest plastic in the world, but this isn't going to be under a ton of pressure. I'm just trying to cover my bases as much as possible. You just never know once you got hydraulic pressure going on. I don't want to have any accidents, because there's going to be sulfuric acid going through here. So I'm hoping that I'll bottom out on the end of the drill, and then with the narrow part of this tap, because this is an NPT pipe thread, so with the narrow part, that'll give me a much tighter, much snugger fit on the threads. But I'm glad I did this test piece before I went and ruined my blocks. And I think that's kind of what you got to do, is run a little test before you jump all in and figure out what you're doing. And there you go. And that's kind of why I end up taking so long doing things, is because I have to think about stuff. I don't process things right away. I have to picture it in my mind and work with it over and over and over again inside my head. I'm good at that. I'm not good with numbers though, but mechanical stuff, gears and wheels and stuff like this, I continually go through it in my head over and over again. If I'm not comfortable, I put it down and I wait. I don't push it. And sometimes a week, 2 weeks, a month will go by, and then all of a sudden I'll be like, oh, why didn't I think of that? Well, I did think of that. That's why I have to take that amount of time. I'm not good at arguing with people either, because it just comes too fast. And, it's like the next day, the comebacks are there for the argument, and, the argument's already over. Yeah, it doesn't mean I'm slow. It just means I'm methodical. I have to think about stuff. This is the only glue that will glue polyethylene. And I got to tell you, I'm pretty impressed. There's nothing here that's really cheap. It's really, you can feel it. It's good quality stuff. They gave you 2 applicators, and you can see they mix the part A and part B as they're going through here. And you have to have one of these, and this gets put in there, and then you can push it. And even this is not cheap plastic. This is glass reinforced. It's heavy duty. It's got a really nice feel to it. I mean, this is not cheap ass garbage here. This is some quality stuff. So altogether, this and this was $55 plus tax and shipping. And so this is what will glue the polyethylene. Nothing else will. You can try, you'll fail. And I was pretty impressed with the tests that they did. They glued 2 pieces of polyethylene together, and for polypropylene. I think this is polyethylene and the tubing is polypropylene. You can glue them together, and when they pull them apart, the glue seam didn't pull apart at all. So that's what I'm hoping for. And the reason I want to make sure there's no leakage is because I don't know how this glue will handle against any of the diluted sulfuric acid, if it comes in contact with it, if it'll degrade it or not. So I want as much sealing as possible. I've done a couple test holes. My hope was to be able to bottom that out on the bottom land there, but unfortunately when I go to tap it, I'm not able to really feel when I'm bottoming out. I've got it all measured, I know I'm getting close, but the tap wasn't able to go enough to give me the threads I needed, and then I ended up wallering out the threads and pulled them out. I went ahead and re-drilled another hole a little deeper, and this goes on nice and tight like I had hoped. So I don't want to go too tight because it gets hard to get out, but the tightness is what I wanted. So I'm probably going to go just a little deeper than that so I can get the full length of the threads when I tighten it down, or at least 3/4 or 2/3 or whatever the threads. So I think I figured out what I needed to figure out with these test blocks. I'm going to go ahead and set up to drill my holes. I'm going to get the holes centered on the milling machine and then get this knocked out. Swamp cooler, good. All right, so here's my setup. I've already drilled one of the holes, got it zeroed, got a center and a collet. And just apply light pressure and then just turn that with the wrench until I get to my stopping point. And then I will rinse and repeat for the next 3 holes. All right, so I found my center line, which is there, at least for that side. I've got to do this side yet. So that way every hole that I drill will come out nice and centered in there. That's how far apart the tubing will be. So I'll get 8 in that row, 8 in this row. That'll give me 16 strands of tubing. I think that'll be pretty good. So if you want to know how I got my center point, it's pretty easy. This is the drill that I use to drill all the way down, and we're assuming that it's a straight shot. I didn't go crooked anywhere. So all you want to do is measure from your outer end outside of the plastic to the outside of the drill bit. Okay, and then what you want to do is you want to go ahead and measure how thick your drill bit is there. So as you can see from here, I've got 77.15, and then this number here is the diameter of that drill bit times 2. So you take the diameter of your drill bit and you divide it by 2. So the diameter of my drill bit is 0.3725, and so you just divide by 2, and then that is your number right there. So what you do then is you take this number, put it into your calculator, and then you're going to subtract this number. Okay, equals. So that's what I need to put into here to find my center. And so that's about as close as I can get the caliper. And so that gives us our center position. So once I put my ink down, then I can just go ahead and, well, just show you right here. There we go. There's that line is the center of that hole. So it's pretty easy. Just your major is here, from here to here. You measure that. You measure your drill bit. You divide your drill bit by 2. Then you enter into the calculator the major number, and then you subtract the half diameter of your gauge gauge pin or drill bit or whatever, and that's how you get your center, and it works with bolts and whatever you're doing. So it's pretty simple, and I'm no good at math. So I've laid down my ink. Looks like I need to lay down a little more ink, but that's my center line. To that hole right there. And there it is, all marked up and ready to go. And we just got to do that block next. So this is the setup. I centered on that line. I just centered with the centered point and just eyeballed it. And then my spacing is 0.6300. And so I drill, then I clear it, and then I move the table 0.6300, and then I drill again, and that's my depth. I mean, I can go deeper than that, but that's about as far as I need to go. And then when I'm ready to ream this, then what I'll do is I'll just go backwards the same way. I'll just put the reamer in, and then 6300, and just back it that way and ream my holes out. That bank is reamed, drilled, and now I'm ready for that bank there, which is going to be offset from these holes. So this bank will start centered to there. And I ended up drilling 9 instead of 8, so I had the room, so why not? So I finished the radiator blocks. They're drilled, they're reamed. I still have some trimmings inside I gotta peck out, which is kind of tricky, but for the most part the radiator blocks are done. I've numbered them 1 and 2. That was pretty neat, huh? Yeah, it's kind of hard to see things without the light on them now, but so you can see I alternated so that see, this hose is going to loop over and connect into there, so it's going to be like coming around, and then this one is going to loop over and connect over there. So I've got nine hoses in each row. It's 18. So that should be a pretty good number to help cool the anodizing bath and keep it right where I need it. So the next video I will be assembling this and getting it all together, getting it glued up, and doing all that fun stuff.